To Pavithra Laptop Care. Today I am going to talk about SPI. See, I have opened multiple schematics here. You can see here flash memory 4 megabyte SPI. Okay, other one here SPI. See, 4 MB, 2 MB, SPI ROM and SPI. Here also SPI, that is SPI ROM. Okay, next see, here also SPI BIOS flash ROM, SPI flash. This is called BIOS chip. See, this is IO controller, and here SPI ROM, AC ROM, but here SPI ROM, SPI bus. Here SPI ROM, which is connected to IO and PCH. Here also SPI, this is connected to SOC and particular chip. Okay, see, in this example, just I will go to page number 28. See here, PCH, SPI ROM, EC. These three are connected each other through SPI. Okay, SPI. What is this SPI? See here, PCH, SPI ROM and EC. And one more example, we can check SPI ROM. We can find it out. SPI ROM. See, here we got SPI ROM 1.8 volts. So today's topic is SPI. We must know about SPI because this BIOS chip is very important to us to do the technical repairs things, motherboard repair. Okay, today I am going to tell you something about SPI. The serial peripheral interface is a digital serial communication interface used for short distance communication, primarily in embedded systems. Okay, in ES we can find what it is. The interface was developed by Motorola in mid-1980s and has become a de facto standard. SPI devices communicate in full duplex mode using a master-slave architecture. The master controller device originates the frame for reading and writing. Multiple slave devices may be supported through selection with individual chip select. You know that CS in BIOS chip, sometimes called slave select. Okay, that CS also is called SS line. Single master to slave. Basic SPI bus example. See, for to know more about SPI bus, we can check this diagram. This is SPI master. See, it has 4 major connections. One is SCLK, MOSI, MISO, SS. Even slave also same thing. Both are same, but one is master and one is slave. See, from master clock will go to slave clock. Even master out, slave in also goes to master out, slave in, slave. Master in, slave out, which comes from slave. Okay, the chip select, the master will select the particular slave, that's called SS. Interface, what are the interface? The SPI bus specifies 4 logical signals. Okay, one is SCLK, serial clock, output from master. MOSI, master out slave in, data output from master. MISO, master in slave out, data output from slave. CSSS, chip select, slave select. Okay, it will be low condition. Output from master to indicates that data is being sent. One is serial clock. See, in many BIOS chip we can see that SCK, SCLK, CLK or SCL, any one name we can see. This is called serial clock, but CLK, this is the clock actually. Okay, see, in this example CLK is mentioned here. Okay, we can see other example, SPI ROM, page number 13. See, this is SPI section, and here also SCLK. See, clock is mentioned here as a SCLK. Here SCLK. Okay, page number 13. You can check DIO, DI. Okay, DI, DO, DO, DI. These are the common name. It's a data input and data output. Slave devices, see, SDI, DI, DIN, SI on slave devices connects to MO, master out, slave in on master, or to below connections. SDO, DO, DO out, SO on master devices connects to MOSI on slave or to above connections. Here I'll show you data output in this. The name DO, DO, DI. These are the common name. It's a data input and data output. Slave devices, see, SDI, DI, DIN, SI on slave devices connects to MO, master out, slave in on master or to below connections. SDO, DO, DO out, SO on master devices connects to MOSI on slave or to above connections. Here I'll show you data output in this. The name given here, it's a SO, SI. Okay, in other BIOS, in any other BIOS, DO, see, DO, DI. Next, master input, slave output. See, master is from slave, it goes to master input. SOMI, MR, ST correspond to MISO on both master and slave devices connects to each other. SDO, DO, D out, SO on slave devices connects to MISO on master or to below connections. SDI, DI, DIN, SI on master devices connects to MISO on slave or to above connections. Okay. Slave select. See, SS, SS, SSEL, NSS, /SS, SS #, slave select. In any BIOS chip, chip select. Slave is not ready for at least one device with one or more such as for an unlocked multiple slave digital conversions. Must wait for at least that period of time. Master will send clock to begin communication. If master configure the clock, if slave is not ready, it is slave by the slave device. Typically, master will during the SPI clock slave, if you want to replace the master, if slave is not ready, it will be in between clocks during slave. SPI clock full duplex. If slave is ready, the master sends a bit on the MOS to the SPI clock cycle. The master reads the slave device while the master sends a bit 0 on master MOS master out first and send the slave reads. already explained the slave means master out and the master will send a signal to slave, so it will wait for that. Already explained you. MOSI means master out and the slave master will send a signal to slave for at least that period of time before issuing slave. It will reads the slave reads the it will read it what the it has got some input. It will send master will send a slave will master the input from master. It will read it. Slave is not the sequence is maintained even when only one direction during each SPI clock master is a full duplex even data transfer. This sequence is maintained even during when only one directional cycle data transfer. Timing diagram. See, I can with the master sends a bit. There also the SPI will communicate with each other, master and slave. And the slave reads in additional to setting the slave diagram. Master will send a clock to slave if slave is ready. Okay, if slave is not ready, it will wait. During each SPI clock cycle, a full duplex data transmission occurs. Okay, in between during each SPI clock cycle, a full duplex data transmission occurs. The master sends a bit on the MOSI master out serial in line, and the slave reads it, while the slave sends a bit on the master in slave out lines and the master reads it. See, already explained you, MOSI means master out serial in. The master will send a signal to slave, okay, that will goes to slave in. The slave will gets the input from master, it will read it and what are the process it want it will do, and again it will send through MISO, master in slave out. Okay, this sequence is maintained even when only one directional data transfer is intended. Okay, even in single data transfer is there also, this process is required. Timing diagram. See, I'll show you the timing diagram. It's very important how the SPI will communicate with each other, master and slave. In addition to setting the clock frequency, the master must also configure the clock polarity and phase with respect to the data. See, particular polarity it will create the clock. It will create a clock with particular polarity and phase, and it sends the data using that. This is the diagram. See, SCK clock, serial clock. This C pole indicates clock polarity 0, clock polarity 1. Okay, clock polarity 0 will be first 0 and 1, 0 and 1, 0 and 1. In this way it will be there. And here clock polarity 1, it's a minus 1. See, first 1, up, down, 1, 0, like this. First it will be high, and when data will glow it will be low, and once it completes polarities then it will be high. Okay, chip select should be low condition. You must remember chip selection should be in low condition. Okay, C phase 0 and C phase 1. Here some little difference will be there. Here see, it's MISO. These are the data bytes. 8 bits is equal to 1 byte. Okay, MISO, master in, slave out, master out, slave in. These are the data with clocks. Okay, this is phase 1. In phase 1 little changes will be there. See, this one will come here and this one will come here. Typical SPI bus, master and 3 independent slaves. We can take an example of a master and 3 slaves. It looks like this. See, SPI master. Here clock signal, each clock signal goes to each slave. See, from master, serial clock is going to SPI 1, SPI 2, see, SPI 3. MOSI, master out, serial in. This also parallelly going to all slave. See, here one MOSI, here it's coming and going to MOSI, and here MISO. this masters in slave out. What are the slave output is there? It goes to master. How it is? This is also in parallel. See here, it's connected to here. Same one is connected to here. All three together going to SPI in typical SPI bus. Okay. Let me check one more example. That is daisy chained SPI bus, master and cooperative slaves. Same diagram, small changes. See, this is master and this is slaves. These are slaves. Same diagram, but one changes is serial clock directly parallelly goes to all three. MOSI, master out serial in, is going to first, but it's not going to second one. What second one receiving, that please observe here, master in slave out, that output is going to second slave to the input master out serial in. Okay, and same thing, master in slave out, this output is going to the other input of the slave, master out slave in, and this output, this final slave output MISO is going to the master. Here chip select will be only one for multiple slaves. In previous one the chip selection will be 1, 2, 3 like that. Okay, because it receives parallel output at a time. Here it's a series. This first output goes to second input, second output goes to third input, and third output going to the master. Okay. Now, what are the application of SPI? SPI is used to talk to a variety of peripherals such as sensor, temperature, pressure, analog to digital converter, touch screens, video game controller, control devices, audio codecs, digital potentiometers, digital to analog converters, camera lenses, Canon EF lens mount, communications, Ethernet, USB, USRT, CAN, IEEE, memory flash, and EEPROM. EEPROM, just now I told you it's a BIOS chip. Real-time clocks, RTC. LCD, sometimes even for managing image data, and any MMC and SD cards. Okay, these are the applications of SPI. Intel announced serial peripheral interface bus. See, Intel launched a SPI bus that's called eSPI. See, Intel has developed a successor to its low pin count bus that it calls the enhanced serial peripheral interface bus, or eSPI for short. Intel aims to allow the reduction in the number of pins required on motherboards compared to system using LPC. Okay, have more available throughout that LPC throughput than LPC, reduce the working voltage to 1.8 volts. See, 1.8 volts, which already is here. See, this one required 1.8 volts, I think so. This is the one. Yes. See, this one required 1.8 volts BIOS SPI. Okay. The eSPI bus can either be shared with SPI devices to save pins, or be separate from the SPI buses to allow more performance, especially when eSPI devices need to use SPI flash devices. See, anywhere you go from BIOS chip to the master, means it's a PCH or IO, some communication will be there. That communication we need to understand thoroughly, then only we can do proper servicing as a technician. Okay, see why I have taken this SPI topic is the signals which is used in BIOS chip, that is very important. Without these signals, the motherboard will be completely dead. Okay, this is very important note. Without BIOS chip, the motherboard will be completely dead. So because of that, I have taken this SPI section today. Okay, that's all. Have practice and just observe in all schematics what is the importance of SPI. Thank you very much.